Students, today we'll see few numericals on Young's double slit experiment. So in that first one, in YDSE means Young's double slit experiment, the wavelength of light used is 5000 angstrom and the distance between slit is 2 mm. Distance of a screen from slit is 1 meter. He has asked us to find fringe width and also calculate distance of seventh dark fringe from the central bright. So first I will write what all is given. So if you take the wavelength of light, he has given lambda. So lambda he has given it as 5000 angstrom. Distance between slits he has given small d, 2 mm. The distance of a screen from slits means capital D he has given. Capital D is equal to 1 meter. Capital D is 1 meter. So he has asked us to find fringe width. So first we will find fringe width. So fringe width, beta is equal to, formula is lambda capital D by small d. Fringe width, beta is equal to lambda capital D by small d. Substitute all these values in SI unit. So 5000 angstrom lambda. So 5000 into 10 raised to minus 10. Capital D is 1 meter. Small d, distance between slits. Distance between slits is 2 mm. 2 into 10 raised to minus 3. If I simplify this, if I take these 3 zeros with this, you 3 0 cancel madida antheliri 10 raised to minus 7. So 10 raised to minus 7, 10 raised to minus 3 cancel aitandre 10 raised to minus 4. So you will have 5 by 2 into 10 raised to minus 4. So if you simplify, 2.5 into 10 raised to minus 4 meters. 2.5 into 10 raised to minus 4 meters. This is fringe width. If you want to convert it into mm, you can convert it. 1 0 you divide, 10 raised to minus 3 you keep, and then you can write it as mm. Second, if I take distance of seventh dark fringe from central bright. So distance of dark fringe from center is given by formula x is equal to 2n plus 1 lambda by 2 capital D by small d. So distance of dark fringe from center is given by 2n plus 1 lambda by 2 capital D by small d. Some of them use it as a 2n minus 1. So even that is also correct, but n value changes. So if you keep x is equal to 2n minus 1 lambda by 2 capital D by small d. So ಕೆಲವರು ಹಿಂಗೆ ಉಪಯೋಗಿಸ್ತಾರೆ, ಕೆಲವರು ಹಿಂಗೆ ಉಪಯೋಗಿಸ್ತಾರೆ. So now for seventh dark fringe. For seventh dark fringe, n is equal to 6. n is equal to 6. If you use this formula, ಯಾವುದು ಕೇಳಿರ್ತಾನ ಅದಕ್ಕಿಂತ ಒಂದು ಕಮ್ಮಿ ಬರ್ತದೆ n ವ್ಯಾಲ್ಯೂ. ಯಾವಾಗ 2n plus 1 ಅಂತ ಇಟ್ಟಾಗ. ಸೊ 2n plus 1 ಅಂತ ಇಟ್ರೆ ಅಂತೇಳಿರಿ, ಡಾರ್ಕ್ಗೆ ಸೆವೆಂತ್ ಡಾರ್ಕ್ ಅಂದಂದ್ರೆ 6, ಫೋರ್ತ್ ಡಾರ್ಕ್ ಅಂದಂದ್ರೆ 3, ನೈನ್ತ್ ಡಾರ್ಕ್ ಅಂದಂದ್ರೆ 8 ಹಿಂಗೆ ಬರ್ತದೆ. ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಅಂತೇಳಿರಿ, ಯಾವ್ದು ಕೇಳಿರ್ತಾನೆ ಅದ ವ್ಯಾಲ್ಯೂ ತುಂಬೋದು. ಸೊ ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿದ್ರೆ for seventh dark n is equal to 7. Answer you will get same. ಈಗ ನೀವು ತುಂಬಿ ನೋಡಿದ್ರೆ ಅಂತ ತಿಳಿರಿ 6 ಇಂಟು 2 12 ಪ್ಲಸ್ 1 13 ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ರೆ 14 ಮೈನಸ್ 1 13 ಸೊ ನಿಮಗೆ ಎರಡು ಸೇಮೇ ಬರ್ತದೆ ವಿಚ್ ಎವರ್ ಯು ವಾಂಟ್ ಯು ಕ್ಯಾನ್ ಯೂಸ್ ಸೊ ಇಫ್ ಐ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಇನ್ ದಿಸ್ ಸೊ x equal to so 6 into 2 12 that is 13 by 2 directly I'll substitute 6 substitute ಮಾಡಿದ್ರೆ 12 plus 1 13 by 2 into lambda capital D by small d 13 by 2 lambda capital D by small d. Now substitute the values of lambda d and small d. So already I have calculated here lambda d by small d I have calculated here. So I will take it as directly 13 by 2 into 2.5 into 10 raised to minus 4. 2.5 into 10 raised to minus 4. So you simplify this, you will have the answer. So if you simplify 13 by 2, 6.5 into 2.5, you will get 16.25 into 10 raised to minus 4 meters. ನೀವು ಒಳಗೆ ಇಟ್ಕೊಳ್ಳೋರಿದ್ರೆ ಒಂದು 0 ಈ ಕಡೆ ತೋರಿ so you'll have 1.625 into 10 raised to minus 3 meters or 1.625 mm ಅಂತ ಹೇಳ್ಬೋದು 1.625 mm. Clear adari? So you can note down. We'll go for the next one. Second one. So in this, in Young's double slit experiment, while using a source of light of wavelength 4500 angstrom, the fringe width is 5 mm. The fringe width is 5 mm. So what he has given? When wavelength is 4500, fringe width is 5 mm. In second part, the distance between slits is reduced to half, he says. So first whatever he has given, if I take lambda 1, I will take 4500 angstrom. Fringe width beta 1 antane, beta 1 5 mm. D1 is equal to D I will take. That is separation between slits. If the distance between slits is reduced to half, so second case ಒಳಗೆ D by 2 ಆಗ್ತದೆ. D2 will be equal to D by 2. What should be the wavelength to get? You are required to find lambda 2 to get fringe width of 4 mm. So beta 2 is equal to 4 mm. Beta 2 is equal to 4 mm. ಈಗ if you observe, in both case capital D is the same. Distance between slit and screen he is not changing. He is changing only distance between slits. Fringe width formula, if I take beta is equal to lambda D by D. Lambda capital D by small d, that is a formula for fringe width. Now if I write this formula for both cases, beta 1 is equal to lambda 1 capital D by D1. Capital D by D1. Or I can say, if I substitute the values, beta 1 is 5, or after taking ratio I will substitute. So first I will take the ratio, then I will substitute. So this is for first one. Similarly, if I write for second one, beta 2 will be equal to lambda 2 capital D by small d2. This is second. If I divide this, so from 1 and 2, I will take the ratio from 1 and 2. I will have beta 1 by beta 2 is equal to lambda 1 capital D by small d1 into beta 2 is divided means it will become reciprocal and multiply. Therefore, I will have d2 by lambda 2 into t. Clearly? So, ಎರಡು ಒಂದಕ್ಕೊಂದು divide ಮಾಡ್ಕೊಂಡೇನೆ. So, here capital D gets cancelled. Now, substitute in one step directly you will get the lambda 2. So, beta 1 is 5 mm, beta 2 is 4 mm. Even if you want, you can change the units to meters. 10 raised to minus 3, 10 raised to minus 3 gets cancelled. Lambda 1 is 4500, d1 is d. d1 is d. d2 is d by 2 into d by 2, lambda 2 we are required to find. Lambda 2 I am required to find. So here d gets cancelled. Lambda 2 I will take to the LHS, this term I will take to the RHS. So lambda 2 is equal to 4500 by 2 into 4 divided by 5. 4 goes to the numerator, 5 comes to the denominator. Simplify madri, you will get the answer. So 5 9s are 45, 900 into 2. 5 9s are 45, 900, 2. So you will get lambda 2 is equal to 1800 angstrom units. 1800 angstrom units. Clear, students? Again you can note down, we will see next one. Now third one, this is from model question paper. In Young's double slit experiment, the slits are separated by 0.28 mm, means he has given small d, and the screen is placed 1.4 meters away. Capital D has given. The distance between central bright fringe and fourth bright fringe is measured 1.2 centimeter. He has given distance of fourth bright, x he has given. You are required to find fringe width and wavelength. First, if I write given things, small d is 0.28 mm, that is 0.28 into 10 raised to minus 3 meters. Screen is placed at a distance 1.4 meters, so capital D is equal to 1.4 meters. Distance of fourth bright fringe from center he has given, x for fourth bright. X for fourth bright he has given 1.2 centimeters, that is 1.2 into 10 raised to minus 2 meters. You are required to find fringe width and wavelength. Beta and lambda you are required to find. So first we will find lambda. From this we get lambda. Then using lambda, small d and capital D you can calculate beta. Now again observe here, students. Distance of bright fringe from center. So distance of bright fringe from center. Bright fringe from center. I will denote it as x and is given by n lambda capital D by small d. Distance of bright fringe is given by x is equal to n lambda capital D by small d, where n is for fourth bright it will be 4, for third bright it will be 3, for second bright it will be 2. So ಯಾವ್ದು bright ಕೇಳಿರ್ತಾನೆ n ದ ವ್ಯಾಲ್ಯೂ ಅದ ತಗೊಳ್ಳೋದು bright ಗೆ. For fourth bright, n is equal to 4. n is equal to 4. ಡಾರ್ಕ್ ಒಳಗೆ ನಿಮಗೆ ಎರಡು ಆಪ್ಷನ್ ಅದಾವ, ಎರಡು ಫಾರ್ಮುಲಾ ಅದಾವ. whichever you want you use it. So you can just rewind the video and go through it once again if you are confused. So bright ಗೆ ಇದು ಒಂದೇ ಫಾರ್ಮುಲಾ ಅದ. So you can use this. For fourth bright, when he says n will be equal to 4. Now substitute. You are knowing x, n, d, you will get the lambda. So x is equal to 1.2 into 10 raised to minus 2, 4 into lambda into capital D. Capital D is 1.4 divided by small d is 0.28 into 10 raised to minus 3. 0.28 into 10 raised to minus 3. Now I will take all terms to the LHS. 1.2 into 10 raised to minus 2, 0.28 into 10 raised to minus 3 divided by 4 into 1.4. This will be equal to lambda. ಇದು ಈ ಕಡೆ ತಗೊಂಡು ಬಂದರೆ ನ್ಯೂಮರೇಟರ್ ಬರ್ತದೆ. 4 and 1.4 will come to the denominator. Now simplify this, you will get the value of lambda. So use calculator and simplify, you will get the value of lambda. So lambda will be 0.06 into 10 raised to minus 5, or you can say lambda is equal to 6 into 10 raised to minus 7 meters. 6 into 10 raised to minus 7 meters, that is wavelength. Now in second step you calculate beta. It's very easy. Beta is equal to lambda capital D by small d. So second, fringe width beta is equal to lambda capital D by small d. Now substitute the values. Lambda you are knowing, capital D and small d also you are knowing. If I substitute 6 into 10 raised to minus 7, capital D will be 1.4, small d will be equal to 0.28 into 10 raised to minus 3 into 10 raised to minus 3. Simplify, you will get the value of beta. So beta you will get 3 into 10 raised to minus 3 meters. 3 into 10 raised to minus 3 meters, or you can say 3 millimeters, you will get the value of beta.